Awakening the black hole. The first such observations. At the end of 2019, the galaxy SDSS 1335+0728 began to shine brighter. Astronomers pointed their telescopes at it to see what was causing it. It turned out that the changes in the brightness of the galaxy were caused by the sudden awakening of a huge black hole in its center. A strange brightening in a galaxy 300 million light-years from the solar system in the constellation Virgo has intrigued astronomers. The galaxy SDSS 1335+0728 was nothing special, but in December 2019 its brightness suddenly began to increase significantly. Astronomers used data from several space and ground-based observatories to track how the galaxy's brightness changed. In a study published in Astronomy and Astrophysics, they concluded that they were witnessing a supermassive black hole awaken from its sleep and begin devouring the gas surrounding it, transforming into an active galaxy and thus becoming one of the brightest solid sources of light. Certain phenomena such as supernova explosions or tidal disruption events, which is when a star gets too close to a black hole and is torn apart, can cause galaxies to suddenly become brighter. However, these changes in brightness usually last several dozen or at most several hundred days. The galaxy SDSS 1335+0728 has maintained this state since its brightness began to increase significantly, more than 4 years after the changes were first observed. A team of astronomers tried to understand these brightness changes using a combination of archival data and new observations from several observatories. By comparing data collected before and after the brightness change, they found that SDSS 1335+0728 now emits significantly more light in the ultraviolet, visible, and infrared wavelengths. The galaxy also began emitting X-rays in February 2024. Black holes are such massive objects that even light cannot escape their enormous gravitational pull. Radiation emission comes from the area surrounding the object. As gas and dust fall into the black hole's gravitational embrace, intense friction and gravity cause the material to heat up to enormous temperatures, shining brightly in space. This behavior is unprecedented, says Paula Sanchez-Sayes from ESO, lead author of the study. The best way to explain this phenomenon is that we see the galactic core becoming active. If this is indeed the case, it would be the first time we see the activation of a massive black hole in real time, adds CO author Lorena Hernandez Garcia from the Millennium Institute of Astrophysics, MAS, in Chile and the University of Valparaiso in Chile. Supermassive black holes, with a mass over 100,000 times that of our Sun, lie at the center of most galaxies, including the Milky Way. These giant monsters usually sleep and are not directly visible, explains Claudio Ricci from the University of Diego Portales in Chile, CO author of the publication. In the case of SDSS 1335+0728, we were able to observe the awakening of a huge black hole, which suddenly began feeding on the gas available in its surroundings, becoming very bright, he adds. The process of awakening a black hole has never been observed before. Previous research has reported that dormant galaxies become active after a few years, but this is the first time the process itself, the awakening of a black hole, has been observed in real time. This is something that could also happen with the supermassive black hole Sagittarius A*, located at the center of our galaxy, says Ricci. Further observations are still needed to rule out alternative explanations, as the galaxy's sudden brightening is suspected to be the result of an extremely slow tidal disruption event. Perhaps it is something completely different, some hitherto unknown phenomenon. If this is in fact a tidal disruption event, it would be the longest such event ever observed. Regardless of the nature of the changes, this galaxy provides valuable information about how black holes grow and evolve, says Sanchez-Sayes. Understanding what causes galaxies to undergo such a transformation could reveal whether our galaxy could one day do the same. a renewable energy source that produces clean energy and absorbs CO2 from the atmosphere. The need to move away from fossil fuels to more sustainable energy production has led scientists to investigate various alternative methods of energy production. In a recent study, scientists looked at algae, a potential energy source that not only does not emit carbon dioxide, but also removes it from the atmosphere during operation. In research published in the journal Energies, scientists from Wisconsin Concordia University described a method of obtaining energy from the photosynthesis process of algae suspended in a special solution and placed in small bioreactors. They can generate enough energy to power low-power devices. A microphotosynthetic power cell, PSC, produces electricity by using living photosynthetic organisms, algae. This offers two advantages. It is a technology characterized by negative carbon dioxide emissions. It generates clean energy and at the same time absorbs carbon dioxide from the environment. In this process, the only byproduct is water. Like humans, algae constantly breathe, but they take in carbon dioxide from the atmosphere and release oxygen. Due to their photosynthetic mechanism, they also release electrons during respiration, explained Philipan Panerselvam, co-author of the publication. The model of the microphotosynthetic energy cell system described in the publication is divided into small chambers separated by a specially designed membrane with microelectrodes on both sides. Some of the chambers are filled with algae and the rest with potassium ferrocyanide. Each chamber measures just 2 by 2 centimeters and is 4 millimeters thick. One of the chambers are anodes, the other, cathodes. The algae are in solution in the anode chamber, while the cathode is filled with potassium ferrocyanide. When algae begin to release electrons during photosynthesis, they are collected by the membrane electrodes, creating a current. Meanwhile, protons pass through the membrane to the cathode and cause oxidation, which will lead to the reduction of potassium ferrocyanide. Oxygen and electrons are generated during photosynthesis. Our model captures electrons, which allows us to generate electricity, said Kiran Kumar Puravinashetty, first author of the study. This system, as admitted by Muthukumaran Pakirisamy, another of the co-authors of the publication, is not yet able to compete in terms of energy production with others, such as photovoltaic cells. The maximum possible final voltage of a single microphotosynthetic cell is only 1.0 V. But the authors of the publication emphasize that their technology is in the initial stages of development and may become more efficient in the future. These types of cells have great potential to become a profitable, inexpensive, and clean energy source. Although they produce less electricity than conventional solar panels, algae energy cells have several advantages. Because they do not require complex ingredients or hazardous gases like silicon solar cells, they are simpler and cheaper to produce. Moreover, their disposal is easy because they are made of biocompatible polymers. As the authors of the publication argue, this process also works without direct sunlight, although with less efficiency.